Okay, let's come back to the problem. If we were in the class, then I will show you the experiments, my beloved experiment with my iPhone and my laptop. I put, instead of this block, I put my iPhone on the top of my laptop and I increase the angle of my laptop a little bit. Then you will see that at the first try, my iPhone is on the laptop without sliding down, right? But if I increase the angle theta a little bit, then if it get the big get value, then the iPhone start to slide down. So in this situation, we can measure the mu s, the so-called the coefficient of the static friction, right? And we call it the critical angle theta c, critical angle. So we can prove that in this case, mu is tangent of theta. So mu s is tangent of theta. Mu k will be a little bit smaller than mu s. Why? Mu s is tangent of theta. I will show you. At this situation, theta will be equal to the critical angle theta c, right? Then we have here the component of the mg is mg cosine theta. The component of that is mg sine theta. And because fs now is the maximum value of that, right? So it is equal to mg sine theta. And the maximum value of the stated friction is equal to mu s multiplied with n. So n here is mg cosine theta, right? Then if you divide the two equations here, you get one at one side. Another one is mu s, right? Mg over mg is 1, right? Cosine theta over sine theta remains, right? So from this one, you get mu s equal to tangent of theta c, right? Theta c over all. Okay, so that's why you have this one. Now, what happens if we let the block slides down? Then what's the acceleration of that? So in case the theta is bigger than theta c, right? Then you have the kinetic friction. Fk equal to n cosine theta, right? Oh, sorry. It's not n cosine theta. It's mu k. Mu k cosine theta mg. Like this. Like this one. Right? And then the acceleration of the object will be mg sine theta minus the fk. So you have here mu k mg cosine theta divided by m. So you will get the acceleration ac, right? A is mg over everywhere, so you can cancel the m from the numerator and the denominator. You get like g multiplied with sine theta minus mu k cosine theta. Okay, let's say in case the block slides down. You got that? If yes, then type the number 9 or number 8, sorry, number 8 in the chat box so that we can come to the next problem. Okay, thank you. Now we have another problem. The motion on the ice surface. Let's read the text and try to solve problem. Rồi, bây giờ trên mặt băng nha, on the ice surface. Then you have the gravitational force downwards, the normal force upwards, they will be cancelled. Then we have only Fk. The puck move to the right, so Fk is to the left. Fk is always up in opposite direction of velocity. Remember that. So Fk vector is in opposite direction with the velocity vector. Remember that, right? Always. So in this case, you have Fk the expression of Fk is mu k n, but because n is mg, so you have here mu k, not mu n, mu k mg. Then the acceleration will be a equal to mu k j, mu kg, right? So we have the acceleration. And then you can apply the equation of the motion here. What do we have? We have the distance. The distance d is 150 meter. The initial speed is 20 meter per second. Can you somehow find the a here? If you have a and you have the equation here, so you can calculate mu k will be a over g. Let's see how you solve this problem. Okay, let's calculate and give me the answer. Okay. First of all, as usual, we have to draw the free body diagram. How many forces are there? For this one, we have two forces, right? M1, M1, the gravitational force Fg1, the tension force, let's say T1. For M2, you have Fg2, you have the normal force, you have the tension 2, and you have the force F. Okay? So we draw the free body diagram like this. If you have the friction, is there any friction? Yes, mu k. So you have here the friction force Fk2. Fk, right? So for the M2 is complicated, right? 1, 2, 3, 4, 5 forces. Okay. They are 1, 2, 3, 4, 5, right? For M1 is easy. So let's write equation for all the 5 forces here and the forces for M1. I write here M1 G plus, let's say T, call it T1. So I have here T1 equal to M1 A1. Very easy. I call this one T2, right? Then T2 is here. So I have M2G plus T2 plus N plus Fk plus F equal to M2A, right? And I remember that A1 and A2 have the same magnitude. T1 and T2 had the same magnitude. And Fk equal to mu k n, right? So they are all the equations we need. Okay. A step further, from the equation for M1, we have minus mg1g plus t equal to m1a. I substitute a and a1, a2, let's say a, and t1, t2 equal t, right? For the second equation, I have the direction of the motion is this way, right? So here, given here, A and A here. So you can see that the f component will be f cosine theta, right? You have to calculate this, take this one only, right? You have fk and t, so minus t minus fk. Fk is mu kn, right? So equal to m to a. For this direction, you have let's say this one is positive, so you have f sine theta plus n equal minus m to g equal to 0, right? So from the equation here, you can draw the n will be equal to m to g minus f sine theta, right? Then you later will substitute n here to this equation. Again, you can add now this equation, and substitute n into that. N will be mk here. What do you get? You have t and minus t. They will be canceled out, right? T and minus t. So I have minus m1g left for the first equation. The second equation is plus f cosine theta plus, sorry, minus mu kn, so minus mu k m2g right, 2g minus f sine theta. This is for the left side of the equation, this side. Equal to the right side will be m1 plus m2 a. Then you can get the acceleration a. Okay, this is a little bit complicated for you at this moment. Okay, let's read it through and carefully, and then ask me question if you have some questions. Okay, so we have A, but now my slide is full, so I go to the next slide so that you can have the answer A. You see, we can get the F so that the formula, the final formula will be better to read. Okay, I show you how we solve for A already, right? If you want to find T, then substitute the A to the last question, the last equation, and then you can have the equation for T, okay? Now, we have another question. If we want to expand this, it's simple. Then we will ask how we can get the maximum value of A by changing theta. So at which theta the acceleration will be the maximum, right? Then this is kind of the mathematics for problem in which you have to find the maximum of a function, right? So let's say A now is a function of theta. You have one theta here, another theta here. So how can we get theta so that A will get the maximum value? In mathematics, you will say that if we take the derivative of A according to theta, like this, dA over d theta, and you put this value to 0, you can get the critical theta. Okay? So how? You see here M1 and M2 are constant. So, and this is constant too. So if you take the derivative of theta here, you will get dA over d theta no. I have the problem in my computer again. Okay. It takes some minutes. Okay. Then you can see here, if I take dA over d theta, what do I get here? I get F over M1 plus M2, right? On are constant. Cosine of theta will be minus sine theta. Sine theta will be mu k cosine theta, right? Then if I put the value of this expression to 0, I will get mu k equal to tangent of theta, right? Or tangent of theta equal to mu k, this one. If you get this one, you put it 0, you get this value. So theta here will be the critical angle so that so if theta equal to the reverse function of tangent, oh sorry, of no, not this one, of mu k, right? Then A will be the maximum. Okay, that's all for today. Thank you for your attention.